Hello. Welcome to our comprehensive guide on staff allocation using IBM Cplex. Efficient staff allocation is crucial for organizations across industries to meet operational demands. Traditional scheduling methods often lead to inefficiencies, resulting in overstaffing or understaffing. This impacts costs, employee satisfaction, and productivity. This is where IBM's Cplex optimization provides a solution by automating staff allocation based on factors like employee availability, skills, regulations, and demand patterns. This data-driven approach enhances efficiency and ensures the right staffing levels at the right times. Now, let's dive into the architecture of this application and see how it efficiently handles staff allocation using IBM's Cplex optimization. The process starts when the user uploads a file through the UI's uploader. This file is then sent to the web server and subsequently stored in cloud object storage. The cloud storage securely holds the input data, ensuring scalability and reliability throughout the process. Next, the Cplex optimization model retrieves the input data from the cloud. It processes this information to generate an optimized staff schedule that precisely meets the organization's needs. Once the optimized schedule is generated, the Cplex model sends the output back to cloud storage. This allows the system to securely store the schedule. The user can then access the optimized staff schedule via a user-friendly interface, where they can easily view, analyze, and implement it. This streamlined process ensures effective workforce management, better decision-making, and improved operational efficiency. Let's jump into the tool demonstration. This is how the user interface looks. Here, we can see multiple tabs, starting with the Overview tab. In this tab, we get all the key information: the model's input, its constraints, the objective of the model, and the output. First, the user uploads the input file using the file uploader. It takes a few seconds to process and extract all the information from the file. Once it is done, we can see details such as the total number of requirements, total employees, and total functions, where functions refer to specific tasks. In the Requirements tab, we see the requirements table, showing the required number of employees for each function or task at particular dates and times. There is also an interactive line graph here that illustrates how many employees are needed over time by function. You can hover over the graph to see values or zoom in, and there's a day-wise filter allowing the user to select a date and view the requirements for that specific day. Next, in the Resources tab, we see detailed employee information in a table, including their name, type, gender, and pay rate. Additionally, there is a gender distribution graph by employee type, showing the count of male and female employees based on their type. In the Skills tab, we have two tables: Employee Skills and Function Precedence. The Employee Skills table shows which skills each employee possesses. 1 indicates the employee has the skill, while 0 means they do not. The Function Precedence table shows which functions are prioritized over others. In the Availability tab, we see details of employee availability at specific dates and times. Also a visualization of this table and a date filter, allowing users to select a date to view availability details for that particular day. Moving to the Constraints tab, we define various scheduling rules. For instance, rest time specifies the minimum rest period required between shifts. Max hours refers to the maximum hours an employee can work in a single shift, while min hours defines the minimum hours required in a shift. Weekly off dictates the number of mandatory days off each employee should have each week. Here, we have two buttons: Maximize Assignment and Multi-Objective. When clicked on Max Assignment, the model runs, taking a few seconds to optimize and generate a schedule. The generated output appears in the Output tab, where we can see which employee has been assigned to each function in the schedule. Now, let's explore the chatbot powered by WatsonX.ai. This chatbot uses an LLM to interact with your data while ensuring your actual data remains private. You can analyze your data in natural language using this chatbot. For example, we can ask, "What is the total assignment?" The chatbot provides the answer along with a filtered table. Next, we ask, "How many employees have been assigned to Shift 2 on the date the 1st of November 2024? It generates the answer along with the corresponding table. Then, we ask, "Show me the value count for part-time and full-time employees and also plot a graph." The chatbot generates a table of the value counts and a graph as well. Now, let's dive into the details of an employee named Abigail. Here, we can see Abigail's assignment on the 1st of November 2024 at 1 o'clock. Next, we make this employee unavailable at this time and rerun our optimization model using the chatbot. After the model is executed, we check Abigail's details again. This time, we see that Abigail is no longer assigned. As we can see, there is no continuity in the current assignment. Now, we will run a multi-objective model and observe the difference. With this model, the functions assigned to employees will follow a continuous pattern. There is also a drop-down menu displaying unassigned functions or tasks. These may be unassigned due to various constraints such as employee unavailability, skill mismatches, or failure to meet the minimum required hours. Welcome to our comprehensive guide on staff allocation using IBM Cplex.